we're going to try to get exact values of angles of pi over 12. Okay. Now these angles of pi over 12, these are not special angles. However, we can express these pi over 12 angles as the sum or difference of our special angles 1/3 pi, 1/4 pi, or 1/6 pi. So an example here, and this is not the only way we can do it, but I can rewrite this as sine of, I can use 1/4 pi plus 1/3 pi. Okay, if I add those together, the common denominator is 12, and I get 7 pi over 12. Okay, anytime I see a plus there, I need to go right to my identity sheet. Okay, I'm going to use an identity to do this. So my identity then looks like this. Sine alpha, which is pi over 4, cosine beta, which is pi over 3, plus sine of the other angle, cosine of the other angle. Okay, so they switch. I can generate an exact value now by just plugging in. Well, sine of 1/4 pi is going to be 1 over root 2. The exact value, I can figure out the cosine of 1/3 pi. That's going to be vertical, long side vertical, which means that the short side is cosine, or horizontal. That's going to be long side vertical, so that means that sine is going to give me the long side, which is root 3. And then cosine is going to be 1 over root 2. So the exact value of that angle, so if I were to draw that angle, it's not quite, it's just past 90 degrees here. Okay, the sine of that angle works out to be 1 plus root 3 over 2 root 2. And this is, we're not finding decimal values for this. We're not going to use any calculators for a problem like this. We're finding the exact value. That's important. The exact value, so we need to use special angles. Okay, so that length here, this vertical length, is going to be equal to exactly that. Now, we could have done it slightly differently, and we could have actually found this same length by using a difference identity. So I could have got 7 pi over 12 by doing a difference. Sine of, I could have started at 3/4 pi, which is 9 pi over 12, and subtract 2 pi over 12, which then gives us to 7 pi over 12. So this would be, give us the exact same position, 7 pi over 12, but now we're going to use a difference identity, and we're going to use slightly different angles here. We're using, this is 135 degrees, and this is 30 degrees. Okay, so we can get the exact same value. I'll just write out what it looks like. I'm not going to actually solve it, but it would look like this. Sine of 3 pi over 4, cosine of pi over 6, minus sine of pi over 6, cosine of 3 pi over 4. So I'm just plugging in these two angles into the appropriate formula. Then I can work this out. Actually, I might as well work this out. Sine of 3 pi over 4 is 1 over root 2. Cosine of pi over 6 is root 3 over 2. Okay, long side horizontal. This is long side horizontal, so short side vertical. Okay, and the cosine of this angle, it's in quadrant 2, so it's going to be negative. So negative 1 over root 2. And notice I get the exact same value as I did using the pi over 4 and pi over 3. Okay, these are exact same, these solutions are exactly the same. So it doesn't really matter if I use sum or difference because it's both the exact position, so we just need to get it in the right position. So same thing here, this is an angle over 12, pi over 12, so we can rewrite this cosine. So I'm going to use, in this case, 9 pi over 12 plus 4 pi over 12, right? And this is going to be 3 pi over 4. This is going to be pi over 3, or 1/3 pi. And then plugging into my formula, it's going to be cos. So cosine 3 pi over 4, cosine of 60 degrees, Since the formula is for cosine plus, it's going to be minus. It's going to be cos, sine, sine. I just plug in those angles into the formula. Once I have plugged them in, I just need to make sure I evaluate this for the correct ratio. So my circle, 3 pi over 4 is over here. Cosine is negative. Okay, so I get negative 1 over root 2. Pi over 3, cosine is the short side horizontal, is 1/2. Sine 3 pi over 4 is vertical, is positive, so I'm going to end up with 1 over root 2. And sine of pi over 3, the vertical is the long side, so it's going to be the root 3 side of that triangle. And then I can simplify this. I get 1, negative 1 minus root 3 all over the common denominator of 2 root 2. Notice we always get a common denominator. If you don't, then we should be a little bit wary of what we're getting. So that's one type of problem that we're going to use the sum and difference angles for. So these angles over 12, pi over 12.